The way to solve these problems is to view them as ratios, and thus we are able to go back to our Singapore math method and blocks as a great way of visualizing these. So let's write out our model, and once you write out the model with all the elements, then the three questions are very easy to answer. So we have moos, quacks, which is one ratio, and they tell you there are three moos in a quack. So I'll write out the blocks at the beginning, but as the numbers get quite cumbersome, we'll resort to numbers. One quack, and then the second ratio is 13 quacks to an oink. Now, for those who are used to Singapore math, you know that I like to put the common um, element together. In this case, the quacks. So in order to be able to relate moos and oink, I need to make sure the two quacks here are equal, which means I need to multiply this by 13. This will give me 39 moos to 13 quacks, which is the same thing as 3 to 1, 13 quacks to 1 oink, which leads me to the fact that there are 39 moos for 1 oink. As you see, we want to keep this the relationship we had determined at the beginning handy in the corner. 39 moos equals 13 quacks, which is equal to 1 oink. First question is, how many moos are there in 3 quacks and 1 oink? Now that we have this table here, it makes things quite simple. We know that 13 quacks, that 1 quack equals 3 moos, or 13 quacks equals 39 moos. We can use either one, which means that 3 quacks would be equal to 9 moos. Combine this with the fact that 1 oink equals 39 moos. Then the two together simply makes 48 moos. Part B, what fraction of an oink does 9 moos represent? Now this question is often very confusing. What do they mean by fraction of an oink does 9 moos represent? Whenever you see the word fraction of an oink, it should basically tell you that oink needs to be the denominator. Okay? So what they're saying is if I have 9 moos, or sorry, if I have 1 oink, and I count 9 moos, what portion of this oink is that? Thus, the only way to do this is to make sure that the oink is converted to moos. Again, our table is very handy up on the left, and we know that 1 oink is 39 moos right here, and that means that 9 moos over an oink is the same thing as 9 over 39, which we can simplify to 3 over 13. Final question, which is probably the most confusing one. 800 moos are sorted into piles 2 oinks high. How many complete piles and how many moos and quacks will be left over? Obviously, again, we have two different units. We have the moos and the oinks, and the key is to convert them to the same units. In this case, we know that 2 oinks are equal to 39 times 2, which are 78 moos. The numbers are quite convenient. 78 times 10 is 780, so I know I will have 10 piles, which will account for 780 of the moos. And be careful here because you have 20 moos left over and you need to convert them to quacks and moos. We know that 39 moos was 13 quack, or that one quack was 13 from our original relationship, which means that this will give us one quack with 7 moos left over. So the answer would be 10 piles, 1 quack, and 7 moos left over. So just a few key takeaways that I feel are important. One is so make sure you set out the model before answering the questions. What I mean by that is you were given some clues at the beginning: 3 moves in a quack, 13 quacks in an oink. And if you waited for each question to do the actual conversion, it will get quite messy and time consuming. What we did, if you recall, we automatically set out the relationship between the three, kept it handy in the corner to be able to always refer to. Number two, make sure you keep the units the same when converting. So every time they ask you things like what fraction of an oink does 9 moves represent, it's a bit like saying if I have 20 cents, what fraction of a dollar is that? You wouldn't say 20 over 1, you would have to convert the dollar into 100 cents. Same thing here, you would convert the oink into moos, or if you wanted to, the moos into oink, but it's much more complicated that way. So make sure you keep the units the same when converting. Keep your work neatly organized, especially when you have to deal with 3 or more different units. As you saw in the last question, you first had to organize a certain number of moves into piles, but the piles were not given as moves, but were given as oinks. And then not only did you have to write a remainder, but you couldn't leave the remainder in moves. You had to convert that to quacks and moos. So make sure you keep your work very neatly organized.